So welcome to session 7 of the Learning Channel, brought to you by us here, spending an hour a week learning Python. I'm going to shut off the music as I normally do in the beginning of the session, and then we're going to go and we're going to start learning. We're going to continue learning about functions as we did as we started in previous sessions. So let's take kind of give a quick overview and introduction as I normally do in the beginning, and then we'll go from there. So your world and the starting point for this whole thing is at iligadfree.github.io/python-learning-marathon. So as you see here, Python Learning Marathon, and we are going through, if you go and start up here, this is a GitHub repository for this whole learning session. Here's the coursework and all the videos that precede this particular video here. And then to start this lesson, you're going to click on this button if you want to start from fresh, if you haven't been participating yet. If you want to start from fresh, just click on this button here, and run Replit will launch it for you in Replit, and it will bring this lesson here. As you remember, in order to run any individual Python function, the way we interact with Replit, we hit a run button to run our Python code. The way we have it configured is we go to .replit. This is the configuration for this particular infrastructure and IDE here, and we make sure to change our line 2 to run equal Python functions.py. So let's hit a quick run here to see what comes out. And eventually I might need to restart this because it looks like it blanked out. And I need so let's bring it back up and hit run again, and all of our prior setups and prior interactions came out. So let's go and do a quick run through of what we've done last class to again kind of refresh on what we've covered and to link it up with the rest of the lesson. So we're going to cover functions to the end today. It might come up short, it might not. As we've seen last time, it was pretty extensive, this whole conversation here, so we'll see how that plays out. But I want to make kind of a logical stop here because next we're going to go into modules debugging and all kinds of other stuff, which is kind of meat and potatoes of how you interact with your interpreter and how you deal with it in the real world. And so it's kind of a big breakdown there, so I really want to isolate these two sessions. Let's take a look at kind of the first run here. So we just did a basic build of a function greetings, right? We kind of went through multiple steps constructing it, and all we have here is a function the way we define it. So we will use def keyword, we type in greeting, and then we pass in value name. We can pass multiple positional values here, right, separated by comma. We haven't done that, we just passed a single value here. Then internally we ran an f string to format a string, and then we return the result. And then when we called it here, ironically calling it donkey lobster, calling greeting with the term Python. Then we printed the donkey lobster, we printed its type, and we printed the type of greeting. And so we got this output here. The output gives us the actual string. It says that return type was string, right? So the return type was literally identified in the context of a function as it got returned. And so now we know that result is a string and the greeting itself is a class function. So that brings us to the note that functions are first class citizens, and they are of type function as they exist in Python. Let's take a look at our passing positional arguments, right? So we talked about an ability to pass arguments that are not explicitly noted for an individual function. So what we have done here, we have created a sample args function, again, just a choice of terms just to make sense within the context. It can be any word as you would name a function. the other thing to note here is that functions are named in Pythonic terms. They named in lower snake case, right? So all individual words are separated by underscores, and all the characters are lowercase characters. So that's a Pythonic way of naming functions. So going back here, we have our positional value test, and then we have other positional arguments rolling into star.args. So the interesting thing to note here is that args is of type tuple. We can actually just add a little thing here just to see that print type args. I'm just going to add that here from the last time. And so we're going to get class tuple, right? So our args, as we roll them up into that call, they're going to be of class tuple. So we call sample args, and then we pass the first parameter that we actually catch. So we print out test specifically, and then we catch a number of following arguments that we do in a star args form. The reason for generally talking about positional arguments and keyword arguments that we're about to take a look at real quick is that you will actually see that in a fair amount of cases used within Python code. So it is useful to be aware of what in the world this means. And so we're going through them here as kind of a primary piece of Python knowledge. That being said, there is, in majority of cases, you will see functions just called with parameters and nothing particularly special beyond that. Let's take a look at passing keyword arguments. So the difference between arguments and keyword arguments is that keyword arguments actually have keys associated with them. So they are a dictionary, and when they are passed in, they're passed in as a key value pair or as a variable name equal value, right? So we're just doing a blanket sample quarks here. Again, sample quarks, just the name of a function. It could have been Dunkelapps, or it could have been anything else, but we just call it sample quarks, so there is no significance to the name. The quarks in the name here, again, is a choice. As long as it is preceded by double star, that what indicates that these are actually keyword arguments being passed in. We call them as quarks because that is a Python convention to call them that. That being said, let's just run test to be sure that I'm not full of it. So if we just run that, it runs just fine, and it prints out quarks is this and that, right? So let's rename it back to quarks, just to be sure that we're following the convention. And so it's keyword arguments. Okay, so what we're looking at here is when we print quarks, let's also print type like we did before, just to kind of for review, print type quarks. And so let's run it real quick, and we're going to see that the type for quarks is dictionary, right? So what happens here is when you make a call on line 49 here, right? When you make a call on line 49, you pick a name for your function that you want to be passed in, and you put a value in. As a result, you get a dictionary with testing as a string key, and 1 to 3 as a value, and supported as a string key, and ABC as a value. So let's take a look at it here. That's what we're seeing in this output. So we created this function other quarks just to see the interesting phenomenon of default values. So default values are leveraging quark capability, and what they're doing is in definition of a function, when you put in a name of a variable you're looking for and set it equal to a value, that creates a default value parameter. So you can imagine plenty of different instances where it can go as far as you are extending an existing function and you want to add a parameter that could be passed in but has a default value, I don't know, false normally, or what have you, whatever you're trying to extend it with, false, empty string, none, whatever is meaningful within that context. So oftentimes this is where keyword parameters are used as kind of this, we have a default value for it, so the interface for everybody else remains, but there's an augmented capability with that value in. So the idea there is that you do have to have the order is important. So like with args, you have to have your positional parameters that are specific, followed by the star args, right? It has to be left is specific, right is general. The same thing goes for quarks. So with quarks, you have to have your specific keyword arguments should be to the left of quarks. They would be at the same time to the right of positional parameters. So that is something to be aware of. Basically, if you swap order within the function definition, it will throw an error to you, right? So if you go in here and do something, throw in test value into other quarks and run it, it's going to tell you that non-default argument follows default argument, right? So it does not allow you to put positional parameters after keyword arguments. So let's just remove it from there. So just to remember that order is important. Okay, so we're looking at this here, right? So we're going to extract this one as a specific parameter. So if we make a call here, other quarks without this one value being passed in, we are going to have this one be available as an empty value here, right? And then if we're looking at the same thing with this one being a specific value, the interesting thing, because these are keyword argument, position is not important. As long as you have variable name assigned to a value, it is going to be mapped to the right value, whether it would go into quarks or whether it would go into keyword argument that you spelled out. And so you get with bunch of others with this value, and then you get this one ends up being with a separate preset value. So that's your keyword arguments in a nutshell. So now let's take a look real quick at our at the big whole here that we kind of looked at. So one of the very important things is to ensure that we do not assign our default values to mutable structures. So like we should not assign it to a list, right? Because if we chose to just modify the variable with the default value that we passed in and we ran it multiple times, as you remember from that experiment, we ended up allocating additional values. So you can see it in the previous video how you ended up with 20 parameters, 20 ones in there as you look through it because of the way it retained it. So an alternative approach would be to default my list to none, to an empty value that's not mutable, and then you would evaluate my list with truthiness, right, and go or empty list. So if my list has no value in it, you can then modify it and append it and whatever, and it's going to be appended only once. So that craziness would be managed here. Okay, so the next thing we were looking at, calling positional and keyword arguments, right? So we just did a mix here and kind of ran it to see how it plays out. Again, your positional arguments need to be prior to your general position arguments, which is star args. Then it should be followed by keyword arguments that are specific, then followed by star quarks. And so that's just all together now, just does the printout for us. There was a pattern that I introduced here, and that was all about potentially using underlying libraries, underlying functionality. So when you have a library that reps a more generic library, so various libraries that writing into database, right? Libraries that writing into communications, what have you. You have instances where you want to pass special parameters to the system below. You want to pass a key like SSL key into your connection or what have you, or any kind of special configuration that a higher level library would not be aware of. It is common for a higher level library to have generic quarks that make no sense within the context of the higher level library, but would be passed as a configuration to lower level library to actually be taken on modify the settings for the lower level library to communicate in a more flexible manner specific to your environment. It's a very common pattern. It is also a common pattern for data staging frameworks where you want to modify specific parameters that higher level kind of functionality, like builders do not need to concern themselves with underlying factors. These are kind of the base two types that come to mind for me, but there are definitely plenty of patterns where you would witness that, so it was worthwhile covering it, right? So you have your our function, which has a positional parameter, first one and second one, and then it passes a bunch of quarks, and then it makes no use of them internally here, and then it passes them below. Actually, decorators would be another, which you would know as a notation in Java and C#. They are using star args and star quarks as your kind of common placeholders, because when you decorate various functions, you do not care most of the time for the content being passed in those functions. You just want to perform some functionality around them. That would be your AOP pattern. We would cover that in a separate session. So yeah, we make a call for our function. We pass a separate parameter here. The other one, unrolling dictionary into parameters, right? So one of the other things that is possible is to actually take a dictionary and pass it into quarks, unrolling it, and so the values are actually going to be mapped out. So the unroll me has the support 1 and support 2, right? And those are have default values assigned, and then we grab a dictionary with support 1 and support 2 as the placeholders, and we run it and unroll it here, and it actually would pass those values in, and it prints it. So that's kind of a quick, well, relatively long, but still a recap of the previous lesson, just to give you kind of a refresher on that. So the next one we're going to do, we want to look at returning multiple values and enrolling them into tuples, right? So that's kind of a relatively rare occasion when you need that, but you do need to be able to do that. And so, in various other languages, you have your out variables that you pass into function definition. With Python, it becomes considerably simpler because you have that capability of tuples unrolling, right? So if we do define sample, let's call it sample tuple, and we're gonna pass in, I'm gonna be very boring here, param1 and param2. And let's pretend that this is our, we have a sum and a difference being passed back. So we're gonna do return, and we're gonna do param1 plus param2, and then we just write in comma and do param1 minus param2. TWO. So what we're doing here, we're doing this kind of crazy expression. It's not really crazy, but it's somewhat kind of odd expression. So let's do so if we're looking at result, let's take a look at result, set it equal to sample tuple, and we're going to pass in 1 2 3 and 2 3 4, and then we're going to do print result from sample tuple. So we're going to pass in that, and we are going to put out result. So we got that here. Let's just run it. Let's do our usual print bunch of equals. So we got a lineup of that. Let's run it. We broke something. Param2 doesn't have an E in it, obviously. Let's run it again. So result from sample tuple is a tuple result, right? So what we did here in this line we went and we said return a sum and then comma a difference, right? And so it returned it as tuple. So as we usually have an ability to unroll tuple, we have we can just write first out comma second out equals to sample tuple. Let's do 2 3 4 3 2 1, right? And then just do print f results from sample tuple and do first out and then do second out. Don't forget to close double quote and stop helping me. All right, so we finished that one up. Let's run it and see, right? So here we got two separate results. We unrolled them from tuple like we know how. And yeah, it comes in very handy, you know, in various scenarios where you need to, you know, return, I don't know, a Boolean value alongside of a value that's coming in, or if you know, if you're looking to enumerate or what have you, right? So we can actually play around with yield a little bit and build our own enumerate using that ability. So this would be kind of the unrolling. So take a second here, then let's take a look at this wonderful world of type hints. So as of, I believe again, Python 3.6. So Python 3.6 was a really major move. Python 3.5, Python 3.6 were kind of really major moves in language, and where various things got introduced. I'm trying to remember if type hints were introduced in 3.6 or 3.7, but I believe they were around in 3.6. And so the idea with Python type hints is even though the language is dynamically typed, the idea of type hints was born, and there were a couple of tools that got added to leverage them. So normally if you do use type hints in your IDE, it would not necessarily be here, but in your IDE it would actually have a it would actually do highlighting within IDE, indicating that you might have called a method of a particular type with a different type. So let's take example and make a simple type hints in there. So we're gonna def I know my types. So we're going to just look at how we would declare it. So my number, let's declare that. So we declare it by putting colon and then putting a type following it, and then my words, and then we're gonna put string. So we're using simple types to see, we're using simple types to indicate which type variables we're going to pass in. So what I want to do here, let's return a Boolean out of this so we can indicate what return type we're also looking for. And then that would complete the definition of the function. So let's make implementation of it, converting my words to int and then comparing it to my number. And so let's say return my number double equals int my words, right? So like if we just make a basic call, test equals, let's do test equals I know my types, and we're gonna say my number is 1 to 3 and my words is 1 to 3, and then we're gonna do print test. I'm just being a bit lazy here, but let's just delineate it again. So do print, do put pluses and do 50 of those. All right, so we're going to run this and see what happens. Right, so it comes back true. So, that's as expected. We have an int that we're passing in, we have a string that we're passing in, and when we convert one to the other, it works, right? Well, the irony of it is that if we do test2 and we set I know my types, and we're gonna pass in 2, 3, 4, comma, and then we're gonna pass 2, 3, 4 as another image, right? When you turn integer into integer, it remains integer. So if we do print test2 and run it, nothing particular is gonna happen, right? So that's a bit annoying that nothing particular is happening here, right? However, if you were in IDE, you would see that it tells you like, hey, you indicated that your type is supposed to be an integer or a string, but you did pass in an integer. So what's happening here? So that's one thing. But that being said, there is also another tool that we have out there. There's a number of tools that you can actually use, but there is a tool that is out there. Let me just that you can use to do validation. So you can edit as your delivery pipeline to just do pass or fail for your test to make sure that it would analyze your code and ensure like all kinds of obvious places where you're trying to call things with wrong types. So for that one, what we're going to do, we're going to reach out to PyPI and we're going to install this package called mypy. And so PyPI is a repository of all the Python goodness. So right now when we were importing various libraries thus far, we haven't imported anything that was beyond Python core libraries. So like random and things of that nature, those all belong inside Python, default install. However, certain libraries that we could have imported here, the Replit runs the system called Poetry, which is really cool. It actually goes through the first runs of your code, and whenever your code gets started, it identifies which packages you need, so it will actually run through and go to PyPI, pull those in, install them, and so from that point on you will have those packages locally. Commonly within your projects you would use the Python package installer called pip, and so what we're going to do right now, we're going to pip install. So let me just zoom in here. So we're going to pip install mypy. So the reason we're doing that is because we are not importing mypy into our code, right? So Poetry would not be aware of us needing that capability within this environment. So we're going to go through and install the packages in here. So the cool part is that, yeah, it's, PyPI has a tendency to be updated with reasonable frequencies, so you would consistently get this kind of messages that PyPI needs to be updated. But this is your window into Python universe, and all the goodness that is open source and out there is your pip. And we're going to look at virtual envs and modules and things like that later. So we're using this package PyPI. So let's rather mypy. So let's take a look at help real quick. So what we're looking for Let me just zoom out real quick because it's getting a little bit crazy. So what we're looking for is to just test. I think I should have just let's see my pipe. So let's just run mypy with the file that we have. So we have, if we do ls-l, we have our functions.py here, right? That's the one we're looking for. So if we're gonna call mypy functions.py, I believe it just needs to run analysis of that, and here we go. Yes, so it comes back with the very error that we were expecting. So functions.py line 111 has error argument 2 to I know my types, has incompatible type int expected string, right? So this is our line 111. This is where we made a call that would be incompatible. So this tool would actually, you can run it through your code, and if you use type hints, you intended things to be called within a certain value, and it would do so. The very common problems that I ran into early in my Python career was we were working on a PR, and both of us were pushing into the same function. We were our code was colliding, and my coworker had written modifications to the function, assuming that an entire model was passed. I was working with the function assuming an ID was passed. My code was working fine because of the way I modified it. His code was working fine the way he modified it. When we ran merge rewrote our code essentially assuming both. And so what happened is that I think it ended up converging on model being passed, and so my code ended up breaking the whole thing in a merged copy. So have we had type hints on this, we could have run it through this type of analysis that would have indicated that the resulting call makes no sense before we just pushed it out to develop. But it was an interesting bug to unhinge. So the other thing that we're capable of doing, we are capable of doing type hinting on collections. So for that one, what we would need to do, I can leave this bug here, by the way, because mypy is not an authority on us running this code right now within this pipeline, so we're just gonna pass through it and it's gonna be fine. All right, so let's take a look at type hints for collections. So for that, we're gonna import. So let's do we can do like an int and a dictionary just to see. So we're gonna go and import. So we're gonna go from typing import. So it's gonna be uppercase list and uppercase dict. So we have these two collections. So the various collections that you would have in Python would be indicated in here. So we can let's do the following. So we do def get values, and we're gonna pass in my stuff as dictionary. And so the way to specify a specific type that you pass into dictionary, you actually use square brackets and you use, say, string. And then we are going to return a list, and we're going to return a list of strings as well, right? So at that point, we have all we're going to do is we are going to just run return, and we're going to do list comprehension. We're going to return value for underscore comma v in my stuff. So what we're doing at dot items. So what we're doing, we're pulling out items from the dictionary that we passed in, and we return them as a list of strings. Let me see, by the way, if this even makes sense, right? Because okay, so yeah, it expect two type arguments, right? So obviously you need to have your let's do string and string. So I use MyPy to make sure that I'm actually producing a sense. So we have the first error still, but the second error is gone, right? So when you declare a dictionary, obviously you need to indicate what type is your key, what type is your parameter. And so now when we're gonna call so test list, we're going to call our get values function. We are going to pass in first one, second two, and then we're going to print test list just to see what's happening here. So if we're running that, let's do the the good old print bunch of dashes just to delineate, and let's run this and see what comes out of it. So we got our 1, 2 that got extracted. If we run test with mypy functions.py, we still get only the first error, the second is fine. So let's check something here. Let's pass in third that is going to carry 3 as a value, which is integer. Let's just see what that does, right? So if we run it, it's going to be fine, right? Because it ignores it at that point. But if you're on mypy functions.py, let's see how good it is at detecting that. So it did detect that we have passed has incompatible type string int expected string string, right? So it did catch the fact that we passed that value in. So they obviously if the type, if a type like that ends up being created dynamically and not statically like that, it might not catch it. So it's kind of the way these things play out. That being said, there are frameworks, and one of them that is a huge deal to me personally. I really, really like it as an alternative to Flask. So there's a framework Flask that is our an HTTP framework, and it is one of the most widely used ones as far as micro frameworks. It is very small, very incremental. A wonderful, specifically API alternative to it is called Fast API. Fast API leverages type hints to like a highest degree, right? So it does it's capable of dependency injections. It's capable of parsing JSON as a parameter coming into an endpoint, which is really difficult in the world of dynamic typing. It's very difficult to do this type of stuff, and so it requires special capability, and so it leverages type hinting as that, right? So type hinting is really coming into power in some frameworks and is a really valuable capability. All right, let's take a look and march on to the next thing here. So I'll give you guys a little bit of space. I'm gonna drink some water here. To let you finish typing and kind of catch up. All right, so the next thing we're going to be looking at is our generators. So the experience that you had with the generator thus far was a function range, right? So we have an opportunity right now to take a look at how in the world it works and what would be so different for it. So in order to produce a generator, we would use a keyword yield instead of return within the function. And out of that, you end up with a lot of really cool capabilities that you can leverage this in. So let's create our own generator. So the way we would define it, at this point, it is just a function, right? So we go def, and let's go my range. So as you remember with our range function, all we were doing, we were passing in a parameter, and we were as like how far do we want to go with that value, and it would return incremental results over time. So what we're gonna do here, we have my range, and then we need to return values incrementally in my range. So we're gonna say our I, we're gonna set integer I to 0, and we're gonna say while, we have not looked at while loop, but we say while I is less than n, right? We can guess how while works from this, right? So as long as while boolean is true. So let's try this. Let's do I equals I plus 1. And then we're going to be, instead of returning, we're going to say yield. I can never get that right. Yield I, right? So we have now created a function that is a generator. What does that mean? That means that we can run a for loop and say for t in my range. And then we're going to say 20, just so we can have it. We're going to just print t. The reason I called it t instead of I, just to kind of show a separation between these two. That's all, right? So, okay, so we got this for loop. Let's do the separators. I keep forgetting them. Print. Let's do another equal signs times 50, the usual here. So now we have this for loop expression. Let's run it and see what happens. So we have our for loop printing out these numbers here, right? So what happens is that we come into our function that we called, we assign I to 0, we start in a while loop, we go add 1 to I, then we run yield, which returns execution individual value, puts into a t, allows us to print it, then it goes back, it comes back from yield and keeps going with while loop. However, as we remember, with range, when we put a value in, it starts at 0 and it comes up 1 short. So what it means is that we need to add I past our yield. So this is where the interesting part with range comes in. We can literally cut that line, paste it afterwards, and it would execute as you would expect. It would take an I in a while loop. It would return the first value of I, which would be 0. Then it would go in and increment it by 1, run through while loop again, yield it again, and go on so on and so forth. And so we get our 0 through 19 as an exercise here. So we have the interesting capability here to do the following. So we can now let's take a look at how we would implement enumerate, right? So we have this enumerate function that we can work with, and enumerate takes a list and it returns a pair of a number of index of a particular item and a value as a tuple, right? So we can create our own enumerate if we wanted to. So we'll create a run def and do my enumerate, and we're going to pass in my list, right? And then we are going to do something like I equals 0, and then for v in my list, we're going to return. You remember how we can return two values, right? We can return I comma v, right? And then after that, we're going to go and say I equals I plus 1. And so now we have created our myEnumerate here, right? I'll let you guys catch up a little bit. So we created myEnumerate, and then we're going to call a for loop, and we can do our index comma value for in my enumerate, and we can do something like, let's put a list in here, 1, 2, 3, and let's just close that up, and then do print an f string, and then we're gonna print I colon I and v colon v, right? So we're just going to print those out running through enumerate. So that's going to be a break, cannot unpack non-iterable int objects. So I'm doing something wrong here. It's because it's not return, it's yield. See that it broke because the returning value was non-iterable because I returned in the while loop, right? So let's run this, and now we have our answer here. I equals 0, v equal 1. Anyways, so we got 0, 1, 2 enumerated for 1, 2, and 3. So we created our own enumerate through the generator here that is sourced from the list that got put in for us. And there are a lot of really neat things that are powered by generator. So the cool part with generators like myRange and like with an actual range generator is that when you say give me 20 values or give me however many values, it will just give you one value at a time. So it doesn't need to allocate 20 values and give them one at a time, right? So if you go million, it's just gonna take up a space of one item at a time. Reading a file could be done inside the generator, so this allows you a way to read one line at a time. And so this way, if you want to read through entire file line by line, you put it into the generator, and the entirety of the file will never be loaded. It will just pull it one line by line, and so this way you can read arbitrarily large files depending on what you're going to be doing with the outgoing data, but you can read arbitrarily large files and actually manage your memory dealing with them. It's really neat, cool thing that you can do. So we have 8 minutes. So let's take a look at switch case that doesn't exist in Python, and then we're gonna take a peek at lambdas and see how far we can get there. It's a pretty tight fit here, but we're going to try going for it anyways. So let's take a look at switch case. So switch case, again, there is no such thing as switch statement within Python. However, we can make one, and we can make one by leveraging dictionaries. Yeah. So the way we would approach that is we would, let's say we want to create 8 subtract multiply divide dichotomy, just because it's a decent example. So what we would do here, let's create a dictionary, and we're gonna make first key as add. That's going to be our so let's do this. Let's wrap it into a function. Sorry, what am I doing? Define calc, and we're gonna do action, and then we're gonna do a comma b. That's all we're gonna do here. So what we're trying to do, we're gonna say action is it add, subtract, multiply, divide, and then we're going to return a result of that. So what we can do here, we can say result equals to a dictionary, and we're gonna say key is gonna be add. It's gonna be a times b. If we have let's do sub. For subtract, it's gonna be, why did I do times? It's plus, my apologies. Plus, it's if we subtract, we're gonna do a minus b. If we're gonna do divide, it's gonna be a divided by b. And if it's gonna be multiply, it's gonna be a times b. Okay, and so the next thing that we're going to do, we are, as we declare the dictionary, we are basically going to call a particular key in that dictionary. So the key for that dictionary should be action, right? So we don't really have default handling here, which is not great. Well, which we could basically put a condition ahead. We'll do that real quick. So we have an action here, and then we're gonna just do return result. And let's do a quick experiment. Let's do print calc multiply 3 9, right? Just to print and see that we get 27 as our output, right? So it's really kind of goofy, but the cool part about it is that we can actually create legitimate switch cases for dealing with this situations here. So let's let's see how we're doing on time. We have 4 minutes, as usual, racing to the finish line here. So let's introduce a notion of lambda. So like any self-respecting language, Python allows you to write one-liners for your functions. And so all we're looking for is a format for it. So we're gonna create test lambda, and we're going to assign it to, so the way you declare it is you spell out lambda as a keyword, and then you pass in parameters that you're actually looking for. So we're gonna say, like, if you just want parameter, you just leave it like that, and then you do colon. If you want multiple parameters, you comma separate them. And so we do, let's do a plus b divided by b. So as you probably have seen with a variety of languages, you really don't type any return statements or anything. All you do is you just put an expression for this system to evaluate, and so it does. So if we do print on test lambda, we can actually call it as a function, I don't know, 1 2 3 comma 2 3 4. So let's do a quick run on that. So we get our float output as a result of it. So what it did is it called it when you declare a lambda. So we can print type of print type test lambda. When we run that, we are going to get that it is class function that we're looking for, right? So we can one line define this function. Do we have a little bit of time for switch case? We do. So the next thing we're going to do, we're going to pretend that we want to return a result in the form of a string. I don't know why we would want to do it, but let's pretend we want to return result in the form of a string out of that. So we can express it in form of lambdas. So we do def lambda calc, just to see how it would fit into that, into the one-liners. And again, this is very contrived. Action a comma b, and then next thing we're gonna do, just crazy use of lambdas, we're gonna straight up return squiggly braces. We're gonna do add colon comma, I'm just putting them quickly in, subtract colon comma divide colon comma, I'm just stubbing this out, multiply colon comma. No, comma is not necessary, even though it would work. And then what we're gonna do, we're gonna put an action here, and we're gonna just straight up return it. And we're gonna make this lambdas. So we're gonna say lambda a comma b colon, and then we're gonna say str a plus b, something insane like that. And then we say lambda a comma b again, and there's gonna be string a minus b. And then we're gonna do same thing, lambda a comma b colon str a divided by b, and then we're gonna do last one, which is lambda a comma b colon str a times b. Let's run this real quick, and then I'll talk about closure, because we actually end up including closure here. So we're gonna do lambda calc, and we're gonna do taking chances, doing division, and we're gonna do 48 6. So let's print that right out of the gate, just so we get it done. Print. Okay, so let's run that. So that didn't work. Haha, that didn't work because of the following. So let's do, okay. So what happened here is we returned a function and not an actual result, right? So we have returned a function, not actual result. Yeah, I kind of botched this one. Sorry, I was hurrying. So let's do underscore a just to avoid confusion. All right, I'm trying to stick the landing here, you folks. Let's do just crazy thing like that. I'll leave it on the screen for a little bit. And so what we want to do is actually call this with a comma b. Run. Okay, so all right, so what happened here, we made a dictionary, right? We made a dictionary with functions in line. So whenever you call an action on this, it's going to pick one of these functions. So when this function is returned, you actually need to pass parameters to it in order to call it, as you would with lambda. Very contrived example, but it's important to note that you return a function, so you pass parameters into it. So there was no closure. You basically just pass parameters to the call here, and you avoided it. And yeah, we're a little bit past time, so we don't have time to look in closure. The idea with closure is that you can declare a lambda, and you can use variables that are external to the actual lambda call that are in immediate scope above, like you would do with other instances. So we'll potentially look at closure within decorators and things of that nature. That would be in later conversations. So I would have to close on this one, as we're a little bit over time, and the recording, as usual, is going to be on the YouTube channel. It's going to be part of the playlist that is linked in the website that we had here in the beginning. And this would conclude the session, and thank you very much.